of a polynomial is the, like, x to the third is a third degree, x squared is a degree of 2. So, okay, now like I said, there's a key connection between these as far as when the slopes are positive, negative, and 0. Okay, so in this original function, give me one interval where the slopes are all positive. From 0 to 2. What do you notice about the derivative from 0 to 2? Is it? The derivative from 0 to 2? It's not negative. Oh, okay. Okay. What happens at 2 to this function? From 0 to 2, it's all what? Positive, right? Look up here, where from 2 to 6, it's all negative slopes, right? Look at 2 to 6 down here. What's true of the derivative? It's all negative, right? Because the slopes are negative, so the values of the derivative are negative. And then it turns around and starts to go up again, right? Slopes are all positive as we go here. So the derivative is positive there. After 6, it's all above the x-axis. Okay? Another way to look at it, wherever the function increases, the derivative is positive. Wherever the function decreases, the derivative is negative. Wherever you have, what are these guys called? Maximums and minimums, extrema, right? What's true of the derivative at those points? 0. Okay? That's the key stuff we want to look at. All right? So the next one, I'm going to draw a rough sketch of a function. I'm going to see if you can sketch me the derivative. Just thinking about that. Where is it positive? Where is it negative? Just the slopes, right? Where are the slopes positive, negative, or 0? And see if you can do it. All right. All right, that's all I'm going to give you. Here's f of x. We'll call it g of x. So here's your g of x. I would like you to sketch for me g prime of x as best you can. Matter. Because remember, we're only focusing on slope, right? Nah, I could, I suppose. And your textbook probably will, too, to try and throw you off. So, sure, I'll put a scale on there. But, yeah, you really don't need it. All right, so let's, or do you guys need more time?
No.
She doesn't. Anybody else? Looks like other people are finishing up still, so I'll let them finish. That's a good point. They chose not to answer. All right. Now, where I always start with these is the zero slopes. I don't know if you guys took that same approach or not, but identifying where are those horizontal tangents in the original graph. And in this case, I pinpointed them for you at 2, 5, and 8. So in your derivative graph here, you should have zeros at 2, 5, and 8 for your derivative. And then the question becomes, okay, so in between these then, is it above or below? How is it intersecting those? So in this first interval, what do we know about the derivative? It's negative, right? So we should be negative somehow. Now, I don't know exactly how negative. Like, it looks like it's about a slope of -1, about halfway there. So maybe it's, right here or something, or I don't know. So in any event, it's going down, though. So we start down there. Now, between 2 and 5, what do we know about the derivative? It's positive, okay? Now, here's the thing. At 2, it's 0, positive, 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 back to 0. So it's going to have to come up and then come back down, right? And think about that. In between, about halfway between 2 and 5, isn't that where it seems like it's the steepest? If you look at the original graph, do you see that? Right about in here, if I were drawing little tangent lines all along this thing, wouldn't the most steep one be about right here in the middle? And as we're closer to 0, to see how those slopes start to get shallower and shallower and shallower, and it's almost 0 until when you get right to here, it actually is 0. Same thing the other way. As we get closer and closer to 5, it's still positive slope, positive slope, positive slope, but it's leveling off until we get to 5. So those slopes are like really steep here and then shallower, less, 0. Okay? So that kind of makes sense that it does one of these then, because you've got very small slopes getting a little bigger and then back down to 0. So some kind of a little hill here, kind of like that maybe. And then from 5 to 8, what's true of that interval? Should be negative. And again, goes from 0 back to 0 again. So this is going to kind of swing around like that. And then the end, it is all positive. And not only that, it's all positive and they're getting steeper, 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 steeper as you go. So the derivative should be getting larger, 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 larger as you go out. So this is going to continue off, heading up. So something to that effect. Okay. Now again, like I said, this goes up exactly. I don't know how far this piece right here goes exactly. It doesn't matter as long as we have this correct shape to it. That's what I'm going to be focusing on when we're looking at sketching graphs of derivatives. Okay, so can we go the other way? Can I give you a graph of a derivative and you work backwards and tell me what the original graph looked like? Let's see if we can do that. So here's a graph of f prime of x. And I'm going to make it a little more interesting this time. You guys are probably like, when he says interesting, he usually means hard. 5, 6, let's say 9. Alright. And then this is, let's say that's at -2. This is 2. Okay, and then this would continue going that way. Okay, so I have a derivative. Let's look at this first little piece here. I have a derivative that is -2 from -infinity all the way up to 3. Okay? So my slope doesn't change. Remember, the values of this thing, everything on the y scale here is the value of the measure of the slope of the original function. We're using slope to go back to what the original one should look like. So I have something that has a constant slope of -2 until I get to 3. What sorts of graphs, what sorts of functions have constant slopes? Lines. Exactly, right? A line, we have slope-intercept form because that line's slope doesn't change. You can put it right in the equation if you write it a certain way. So from -infinity up to 3, I should have a graph of a line that has a slope of -2. So I'm going to jump down here and do that. Yeah. And you're trying to go the other way again. This is the derivative. This is not the original function, right? So every y value on this thing is a slope. So we're working back to the slope of the line. So yes, we got a slope of -2. So up to 3, I need a slope of -2. So here's a question, though. How do I know how high up or how far down that line is, right? Because all I know about that line is it has a slope of -2. So shoot, I could have a slope of -2 like up here somewhere or down there somewhere, and it's still fitting it, right? And the answer is it doesn't matter because there are several functions that could have this same derivative. Okay, and we're going to get into that a lot more later. But for now, just know I just need to make it a line that has a slope of -2. So let's see, if I have, let's put this up at, say that's 3. This is -3. So if I want a slope of -2, go down 2 and over 1. So maybe it looks something like this. Okay, if you calculate that slope, rise over run, down 6 over 3, that's -2, so that works. Okay, so we've kind of matched that part up there. Okay, then from 3 to 5, what do I know about the derivative? It's positive slopes, right? Remember, this is measuring slopes. So from 3 to 5, this is positive, which means this particular function needs to be increasing. The slopes are positive, right? So it's going up. Okay, then at 5, what happens? It hits a maximum, right? And it has to be a maximum, not a minimum, right? Because this is positive slope. So we're increasing, and then at 5, hit a maximum, and then from 5 to 9, it's negative, which means it's going to decrease, right? Then at 9, it hits another 0, so it's going to be a minimum, and then it's positive again, and it's going to come back up, okay? So I know it's kind of hard to think about sometimes. You got to have to think it backwards a little bit. But even though this is decreasing right here, the fact that it's above the x-axis means this is going to increase. So I'm going to take this thing and have it start to increase until I get to 5. So maybe it does something kind of like this. And it doesn't have to go over that x-axis. All I know is it's increasing. Then at 5, I'm hitting a maximum. And then it's going to decrease until I get to 9. where it's going to hit a minimum. I should make this axis a little straighter.